we have more complicated piecewise defined function to graph. The word piecewise defined function, just call that piecewise function. So what are the two things to remember? The first thing you have to remember is the shape of the parent function, right? So for example, let's say the first function 1 minus quantity 1 minus x minus 1 square. You see that there is an x, there is a square, so the graph will look like a parabola. And then the other one, square root of x minus 2, you should know that this graph must be similar to the graph of square root of x. Okay, so first piece, when x is less than or equal to 2, I will just use table value to guide me through. So when x is equals to 2, what do we have? 1 minus 2 minus 1 square. So that is 1 minus 1, 0. So you have a 2 comma 0. So 2 comma 0 is right over here, right? So this is a 2. We have a 2 comma 0. When x is equals to 1, 1 minus 1 square. So this is equals to 1. So you have a 1 comma 1. And then 1 comma 1 is right over here. That is 1. And then when x is equals to 0, so x is equals to 0, I will just go down like that. When x is equals to 0, we have 1 minus 0 minus 1 square. That is equals to 0. So we have a 0 comma 0, and then 0 comma 0 is right over here. And then we have x equals to negative 1, 1 minus negative 1 minus 1 square. That is equals to 1 minus, this is a 1 minus, 1 minus negative 2 square, which is 4. So you have a negative 3, right? And then you just plot that. So negative 1, negative 3. You plot that, and then now you see the shape of the parabola. If you just go up and down like that, you see the shape of the parabola. Okay, so that is the first piece. And then how about the square root? The square root is x greater than 2, so I will still pick x equals to 2 in case you argue with me saying that there is no equal. We do that anyway. I will show you how to deal with this. So you have the square root of 2 minus 2, which is equals to 0, 2 comma 0. I will just use this as an open circle. So when x is equals to 2, y is equals to 0, this is going to be an open circle. So what happens when you have an open circle on top of a solid circle? We keep the open circle anyway. So we keep the open circle anyway. You don't have to write it out. So when x is equals to 3, we have the square root of 3 minus 2, which is equals to what? 1. So we have a 3 comma 1. So this is a 3 comma 1. And then when x is equals to 5, so x is equals to 5, square root of 5 minus 2, which is equals to 3. So we 3 is approximately equals to 1.4, right? So square root of 1.7. So that is approximately equals to 1.7. We have a 5 comma 1.7 or 1.73. So when x is equals to 5, we have a 1.73. That is about over here. And then how about, what is the biggest we can go? 6, 7, 8, 9, 10. So how about x equals to what else can we do? Can we do a 11? So when x is equals to 11, we have the square root of 11 minus 2, which is equals to 9, right? So the square root of 9, that is equals to 3. So when x is equals to 11, y is equals to 3. So we have a 11 comma 3. Like that. So now we get the shape. The shape looks like this. And that is similar to the shape of square root of x. So now the graph is finished. Let's move on to the next one. The next one, what happened here? What happened when you have a open circle above and solid circle? We keep the solid circle anyway, because when x is equals to 2, I will just plug in 2 to the first piece. All right. So x square root of x plus 4, x less than 0. So I will choose x equals to 0, and then 4 plus 0, the square root of 4 is equals to 2. 0 comma 2 is an open circle. So 0 comma 2, this is an open circle. And then how about the next one? Let's pick a negative 2. When x is equals to negative 2, 4 minus 2, that is the square root of 2. Square root of 2 is around 1.41. So negative 2 comma 1.41. Negative 2, 1.41, that is about here, right? And then when x is equals to negative 4, x is equals to negative 4, so we have 4 plus negative 4, so that will be a 4 minus 4, which is equals to 0. So we have a negative 4 comma 0. So negative 2, negative 3, negative 4 comma 0, and then we should stop, because when x is equals to negative 5, 4 minus 5 becomes negative 1. So when x is equals to negative 5, we have a 4 minus 5, we have a x equals to negative 1, that is undefined. So the furthest we can go is a negative 4. So therefore we connect them. Okay, and then this is a 0, right? And then this is 2. Okay, what about the orange piece? The orange piece, I will pick x equals to 0. This one is a 4 minus 0 equals to 0. Equals to, why do I say a 0? 4 minus 0 equals to 2. The square root of 4 minus 0 is equals to 4. The square root of 4 is equals to 2. So we have a 0. We have a 0 comma 2. So we have a 0 comma 2. So this is a x equals to 0, y equals to 2. So this time we have a solid circle on top of an open circle. So when x is equals to 0, y is equals to 2. Just fill it up. And then when x is equals to greater than 0, right? So I will pick x equals to 2. We have the square root of 4 minus 2, which is equals to 2. So we have 2 comma 1.41. So 2 comma 1.41, so 1.41 is around there. And then when x is equals to 4, that is the highest we can go. 4 minus 4 is equals to 0. We have a 4 comma 0. So 2, 4, we have a 4 comma 0. We have a 4 comma 0. That is the highest we can go, because as you go above 4, like 5, you have a 4 minus 5, that is undefined. So the 4 is the highest we can go, and then we do this. Now, we have a solid circle on top of an open circle. We still fill out the open circle, because when x is equals to 0, x is equals to 0, y is equals to 2, because I will just plug in the 0 to the second piece. Alright, so that is the end of this video. If you like the way I explain graph a piecewise function, give me a thumbs up, a subscribe. Truly appreciate your subscription. As always, meet you all in the next lesson. Signing out.